All right, so let's get down to the topic of today. Speaking also of Sec4Dev, Andreas Falk was one of the speakers last year and also had a bootcamp on microservices security. It was Java-based security bootcamp. And now we have him here again for this meetup, this time talking about the testing pyramid. I think people often have a hard time getting security into the product. And when things are moving fast and we want to be agile, we want to be able to react fast on new requirements and so on, how am I gonna? I'm not gonna be doing a penetration test every 2 weeks. That's not possible. So there will be some things that I have to automate away. There will be some baseline that I want to ensure in an automated way. And there are different types of tests that you can use for this purpose. And Andreas has today in his talk is gonna present it with some security testing pyramids. So types of tests you can use for different purposes to ensure, in this case, software security. And I'm very much looking forward to Andreas' talk. Stay tuned. Ask questions also in the Q&A section of Zoom. Andreas, either you answer them right away, or if you're just in the flow, don't worry. I'm gonna be asking those questions at the end of the talk. And so we're gonna have a Q&A session at the end. So please, Andreas Falk, looking forward to your talk.
Okay, thank you very much. So I will share my screen. So hopefully you see my screen already.
Yes, we do.
So it's about the security testing pyramid, actually. So I sneaked in some security into the testing pyramid that is probably well known to most of us. I will also present some practical code stuff. If you want to look into that, there's a link to my GitHub repository for that. It's called the bookmark service, an insecure bookmark service actually at the moment. So it's by intention, I put in some security weaknesses into that project. So about me, I'm Andreas Falk, as mentioned. I'm located at Stuttgart, south of Germany. I'm working for a company called Novatec Consulting. So we actually also offer trainings for security, but not in Vienna, but in Stuttgart. So if you are located in Stuttgart, in Germany, you can also visit our security trainings. So we've also a base one-day security training as introduction for application security, where especially you can also switch sides. So we also have a training application where you can hack and also find security problems in that training application. So I'm also a member of the OWASP, the Open Web Application Security Project community, and also part of the OpenID Foundation. So I also take part of several communities in the security area. So what is the topic of today? So I think most developers already know that what is called the testing pyramid, originally invented by Mike Cohn several years ago. And the idea here behind the testing pyramid is that we have plenty of unit tests. So this is the majority of unit tests called the regression test suite. So for example, if each time if we detect a new bug, a new issue in our software, then we should also write a regression unit test tackling that bug so that this does not happen in the future anymore. And with that, we get a safety net with lots of unit tests that we can run really fast in some seconds and get fast feedback if something has broken our application or everything still works as expected. And so these tests are easy to write. We should have really many of them, of these tests. And these tests are running really fast. So you should get feedback in some seconds for each test. So the next layer are the what is called service tests. These tests take a bit more effort to write. They also take a bit more time to run. And these tests typically also tests in containers, like in booting up a Spring context and stuff like that. So real integration testing. but on the API layer usually. And on the top level, we have the slowest tests and also the tests with the highest efforts to write them, called the UI tests, like, for example, Selenium tests, so acceptance testing, stuff like that. That is hard to write and also hard to maintain over time. And we should not have too many of these tests because otherwise it gets too expensive for maintaining these things, and these tests tend to break more easily than the unit tests. And there's also an advanced version of that testing pyramid by Janet Gregory and Lisa Crispin, who have written a agile testing book. So they call these tests here unit tests, component tests. So the programmer facing tests. So developers really love to write unit tests because they are so easy to write with their frameworks like JUnit, for example. JUnit 5 has lots of great features nowadays to write such a test in short time. And then they also love writing tests like, for example, Spring integration tests, testing the business logic, testing if the REST API works as designed, stuff like that. And above we have the workflow tests, again, the acceptance tests like Selenium and stuff like that. And on the top of it, we have the manual tests and also explorative testing. So these are the tests we always need some human resources for, and so that's why we should not do too much into that area, because that always takes some human resources and is quite expensive. So what about security? So we did not see any security mentioned in this pyramid. When we look again at Gregory Crispin of the Agile testing book, so they have defined also that Agile testing quadrants, where they also split tests in different focus areas, like, for example, also the technology-facing tests that guide development, like the unit tests for the developers. Also tests that are then more business-facing, like UX testing, prototypes, simulations, stuff like that. Also explorative testing they have tackled, and also user acceptance testing, usability testing. And on the right side at the bottom, you finally find what is called security testing, together with the other quality testing like performance testing, all these ilities testing like availability, testability, maintainability, and stuff like that, testing for all these quality attributes of a software. Some people always also call them as non-functional tests. In lots of my projects, I'm confronted with some requirements regarding security, where the manager then comes up to the development team and tells the development team, oh, we have to tackle the OWASP top 10. Make sure that the application is secure, and you can check all the top 10 lists of the OWASP top 10. And then the developers ask themselves, so how actually should we do that in our application? So especially if they have no knowledge in application security, then we get lots of question marks. So what actually means how to make my application secure with the web application security, with just by handing them the OWASP top 10 list. So the OWASP top 10 list is a quick start, but I don't find this list very useful. It just mentions all the bad things that can happen, but does not give really handy hints how to really tackle this stuff. So this is a typical problem. So how to get concrete security requirements for my project. So we have a really useful other standard provided by the OWASP, the application security verification standard, where you get a big catalog of typical security requirements, and you can just check if these requirements are applicable for your project. Then you get also hints how to verify and test these requirements. Another quite helpful testing guide is the web security testing guide, which also includes really helpful ideas how to test for security. And with these two guides, you then finally get your security tests that you should write. I also got ideas for the testing pyramid out of these two guides, actually. So what is included in the application security verification standard? So you have really helpful a catalog of different fields, starting from architecture, design, and threat modeling, authentication, session management, all that stuff, but much better than just looking at the OWASP top 10 list. And there's another up until 14 chapters, also regarding configuration, how to make an API secure and stuff like that. And the idea now is which security requirements could probably be tested on which layer of the testing pyramid. So we will start at the unit testing layer, so at the bottom of the pyramid, and you now see a slightly different picture of the security testing pyramid. In red, you see marked the unit testing layer. And on the right side, you see a list of what could probably all be done on that bottom layer. So it all starts with what is called static application security testing, which actually is not about writing a test, but just running static code analysis tools. And there are different tools available, like Spotbugs, which is very prominent for Java developers. And you have SonarQube that also has lots of static code analysis regarding security insights, especially the most current version. They added much more security into it, also tackling JavaScript, TypeScript, and stuff like that, in addition to Java. Also, Kotlin support, for example, has improved pretty much there. Then you can also tackle third-party dependencies at that stage. So find vulnerabilities in your other frameworks like Hibernate, other Spring dependencies, Jackson dependencies for JSON support and stuff like that. And the most interesting part is what you can tackle actually at the unit component test level. So you actually can handle security architecture questions at that stage. I will also show an example using Arc units, how to tackle some architectural stuff in your projects regarding security. You can also check if you have information leakage via error handling, if your errors get too much information out to the third-party world, stuff like that, or simply if somebody could bypass your intended business logic. So that's a typical use case of a unit test usually. So to test if your application does what is intended, and you can also write negative tests in your unit tests to try to bypass the intended business logic. That's what attackers usually also want to do. Then you can also tackle things like broken authentication, or also tackle partly injection vulnerabilities by also testing for input validation. So for static application security testing, you can use several tools, like, for example, SonarQube. I've done some scanning for that application that I've mentioned on my GitHub repository, which has some security problems in it. So we can see that in the security hotspots. So I just scanned it today. As you can see, it detected a cross-site request forgery problem. It detected 5 SQL injection problems that I also put inside the application. So that's a typical case of Sql injection vulnerability just by string concatenation using a native query. I'm actually using Hibernate as framework, but even with Hibernate, you can then via the entity manager create a native query and then get back SQL injections. So that's already detected by that tool. Also some stuff like weak cryptography. So I implemented hashing algorithm using MD5, which is broken to hash my passwords actually. So that's also detected. So it really detects lots of nasty things already on that level. So that was that part on static application security testing. You can have other tools like oh, I forgot to show the other tool I also have. Since short time, there's also Sneak available, which is a commercial tool for static application security analysis. But even with the free version, you can integrate that into your IntelliJ IDE. Just get a free account on Sneak and then get your API key configured in IntelliJ, and then you can just run a scan using Sneak for your application. That should be also quite fast. It just runs and then downloads the analysis from the server. It also detected a SQL injection here. Also in some part here where I have used GDBC in a pure version. So also again a problem with SQL injection. So it actually detected other location than SonarQube. So if you use different static analysis tools, then they also tend to detect sometimes different things. Like for example, SonarQube did not detect cross-site scripting, but Sneak also detected some problems for cross-site scripting because I have a reflected response here without checking the input and without a validation input. So we have that as well. So we also have the same problem with the MD5 password encoder, which is bad, and also some special things like hard-coded passwords that I have in my source code actually, which is also a bad thing. But this is just for testing purposes, for getting some test data into my application. So for me, that's quite okay. But don't usually check in such code in your production-ready applications. So the next thing would be then getting really into write tests for security problems, like for example for broken authentication. Here I just got some part of the ASVS again. So this is what requirements in the application security verification standard looks like. I just have chosen password security requirements in that case. That requires some stuff like that the user can set passwords that are at least 12 characters in length, and they also able to set passwords that even can have 64 characters or longer. So I hate services that tell me, so if I generated a really good password with my one password manager, for example, and then they tell me, oh, my password that is 25 characters long is too long for my service. So shorten your password, that's always bad. So that's not a thing we should have. So there's no problem to make it 64 characters long or even longer. So there is sometimes a natural frontier at 128 characters, depending on the hashing algorithm used, but otherwise there is no limit. and also verify that password truncation is not performed, for example. And you can even use any printable Unicode character, even emojis in passwords. And this is also in according to the newest standards by NIST and also the German BSI. They also recommend almost the same requirements here. And the testing guide then adds useful tests to verify such things. And now I want to show that in code how you can actually test such things. So I've implemented a really simple application, just providing administration of bookmarks, like you can do it also in your web browser. So for every user can just save some bookmarks. So I have administration of users here. And for user, you can then just post your bookmark or get bookmarks for each and every user. So just to get bookmarks of a user, you have to specify the user ID to get bookmarks for, and then you get the bookmarks back. So we can even check that out here. So then we basically get some lists of bookmarks, like for example, here we have Amazon.com or eBay.com with the URLs. And so that's a really simple use case for that service. But even for that simple use case, you can do lots of things wrong. Like, for example, there is a problem with getting the bookmarks. Actually, there is no authorization test, for example, implemented. So that everybody could just also use another user ID to grab the bookmarks of another user. There is no authorization check. So that's also one of the weaknesses I put into the application. And we also have some open API documentation for that. That is quite useful for the third stage of the testing pyramid, the dynamic security scanning later on. So regarding the tests, what I wanted to show is that we can really test for password security requirements according to that requirements here. I also set up display names on the tester. So if I run the test, you can see tests for each and every requirement of that ASVS requirements document. So for example, we have a test that makes sure that that passwords are at least 12 characters in length. So you should have an implementation according to that makes sure that you can only register users that use passwords that are longer than 12 characters. So we can test that one here. So we can also test that longer passwords are possible. We can also test if you have a long password that it is really not truncated. So it's equal after creating that user with that password. You can even test if emojis, Unicode stuff can also be used as part of the password and does not have any problem in your application. One test is not implemented at that stage because for that you would need an integration test to actually test on your real REST API that users can really change a password. And then also again that they can also change the password that is requiring the old password for verification. That cannot be tackled on the unit test level, but this can be tackled on the unit test level. You can also compare passwords for registration against breached passwords. There are lots of lists available, like for example, Troy Hunt puts out a service where we can find breached passwords, but we have also the top 1000 lists available on the internet with bad passwords that are well known in databases. So you can easily test against a downloaded list of well-known passwords that users are not allowed to use again. And with JUnit 5, it's quite handy. So you can use parameterized tests. Just having some different inputs and then checking against if the breached passwords are allowed or not. We have also some tests that cannot be done on the backend, but at least these are documented here as well. So verify that the password strength meter is provided. Then we should also have tests on our front end, like the Angular application and stuff like that. So today we are just tackling the backend. That would be a topic of a following talk, how to test these nasty things like cross-site scripting or password strength meter on the front end side. Then we also have some composition rules. So I always also hate too complicated composition rules, like you need 2 uppercase characters, you need 2 special characters combined with at least 2 number characters. That makes things really worse for the people to find a suitable password. So you should not have people think over 15 minutes if they can get a password that is according to the regulations. And we have sequential rotation is required, that can also be tested on integration testing level. But at least it is documented why this is not tackled on that level. And we can just try to execute that test. Because in this intended insecure applications, so most of the tests will not run fine, because we did not have so it cannot be longer than 64 characters. So that's a problem here. And it's also not tested against set of breach passwords. So we have lots of things that are not according to the requirements, and we should get rid of them, and we should fix them. So with that test, we get some hints that we have problems regarding password security requirements. So next thing would be, for example, also tackling input validation on unit test level. So here I have a test that also validates input validation requirements from the ASVS, like, for example, that we have that we only can supply valid usernames. In my application, a username, in fact, is an email address, so it should be formatted and should be a valid email address, actually. So it should not be possible to sneak in like here some JavaScript stuff or nasty Sql injection tryouts or some stuff that looks not like an email address. So we just test for these nasty things, so that should be not accepted in our user interface for creating a user. And for that, we just use the bean validation functionality that is part of Spring framework, using the Hibernate validator out of the box. You can easily just instantiate that validator factory also on unit test level. And we also have a test that tests that valid the valid usernames are accepted. So valid email addresses should be accepted, like this one or that one. So you can also hand in different valid options. So let's try that test again. So as you can see, the tests for the valid ones are green. But all the invalid ones are red, because these would be accepted by our application currently. So I have to mention that in the application totally misses completely all input validation. So we have no input validation at all. So we also do not have any strong typing. So if we look just at the user, for example, so there's no input validation implemented, like, for example, like the typical ones would be like the not null constraint, not blank, not empty constraints, stuff like that is not implemented. Or you can also have the validation for email address, which is provided by default by bean validation. So we do not have all these stuff. So with that input validation test, you can easily just detect also missing input validation stuff that should be validated. Yeah, that's so. We also do not have that on the entity bean as well. So we have the user entity that is mapped. So actually, we also have only not empty on that stage. So here we have an email address at least. But if you just put that into your REST API, then this is not checked at the first stage, which is also really bad. So that was what I wanted to show regarding unit test level. You can test much more on the unit test level actually. So you can also then test if business logic is bypassed. Like for example, also if you fails in a secure way, if errors happen. Like for example, Spring Security requires some tests like a user detail service to be implemented, and you can also test such helper classes that are required by Spring Security in unit tests if they also throw that intended user not found exception if something happens that is not intended. So it should not be possible that a user just gets in when an unknown exception happens. So that was the demo for the unit test level. On the service test level, you can then tackle your REST API, for example. Here you can also test input validation in some deeper form, but you can also test authentication, authorization, test if your session management works as expected, and also tests output escaping on the backend side. It's always a good thing to also tackle already output escaping on the REST APIs, so that not the complete responsibility lies on the front end, but you can also use frameworks like the OWASP encoder framework and stuff like that, or the Google Safe HTML type projects on the server side to handle all that output escaping stuff to prevent cross-site scripting already on the backend server side. Because even if you have a front end like Angular that is really good on defense on cross-site scripting, you never know where your backend is then also reused for some other stuff, for some other front ends that are not that good at defending against cross-site scripting. Also, injection like Sql injection, I will also show a test shortly showing how you can detect Sql injections. Also, security misconfiguration can be checked at that stage. So what I have chosen here is a typical thing of broken access control. So you should also test if you enforce access control rules on a trusted service layer. And also the testing guide then hints that you should always test access for administrative functions, and also then do the negative tests to the same resources if a user with a standard role does not have access to this administrative function. This is what usually is forgotten. People just test their endpoints if the administrator role can access this function, but they forget about to test if I'm not administrator, then it should get an access denied instead. And by that way, it is always forgotten that there might be a leak in your permission model that also makes it possible that a standard user can access these functions. And authorization should also always be tested on different layers. It's not sufficient just to test authorization on the URL layer, on the UI level layer, because with tricking around with some bad encodings and stuff like that, attackers also manage to get around some URL pattern matching regarding authorization. So at least also test on the service layer, like your Spring service components. And if you want to make it perfect, then also then test it again on your data access layer as well. So to restrict all data coming from the database for a specific user, for example. So we can also show some tests on that level. So for integration tests, we have a bit more tests available. So if you can see, I have defined a typical REST controllers like we do it on Spring usually. So like for the bookmarks, we have a REST controller. We have some services defined here for search bookmarks, for example, which if you look a bit deeper here, also has no restriction so everybody could just search bookmarks, also bookmarks of other users. There is no query parameter restricting the user and stuff like that. So that's also bad implementation in that stage here. And if you look at the bookmark service, then you will recognize that the bookmark service search functionality also has problems with Sql injection. So you basically can, with using a Sql injection, get all the bookmarks without knowing any information what existing bookmarks we have. So these are typical problems in this application. And I mentioned that we can also test authorization pretty good using Spring Security in that case. And this is tested on 2 different layers, actually. We can test that on the first layer, on the web layer. For that, we just use the mock MVC approach on Spring that just tests the web layer, actually, and mocks away all the business logic behind it. The database is mocked away. So we just have the mock MVC. And for the user service, this is just a mock bean that does pretty much nothing. So we are sure that we just tackle the web layer authorization this time, and not the authorization layer on the services. And here you can then test if my API getting a list of users that should always only be accessed by an administrative user. So not everybody should see all the other users that are available on the system. Just a user with having the role admin should be able to do that. In that case, I added a positive test that tests if the admin user can access this endpoint, like API users, and the other one cannot tackle that one. So I have the negative test as well in that case. For authorization, it's also good to test in addition for cross-site request forgery stuff. So that's also a typical problem that often people forget to enable cross-site request forgery prevention. And so we can also test that in an automatic fashion. So we can test if we don't provide any CSRF token, that it should be forbidden. And if we provide such a CSRF token, which can also be simulated in the test with that statement here, then we should have a positive feedback. So maybe just try to run the tests. And we again will see that the implementation is not as expected. When running these tests, you will recognize this is an integration test. It runs much longer than the unit test we had before. So as you can see, so we have a negative test here. So even a user without a valid CSRF token can be created. So we got 201 for HTTP status created, but expected was 403. That would be the correct answer if we don't provide a CSRF token. So of course, with a valid CSRF token, it can be created. So that was expected, but this is quite unexpected. We should tackle it. So I just also implemented in a bad fashion at that stage. If you have a look here, this is what you should usually not do. On Spring Security. If you have session cookie-based authentication, then you should not call CSRF disable. So that's why my tests then fail at that stage. So they prove that CSRF protection is not in place, which should be. And also the authorization enforcement is bad because we don't have any rule defined here that prohibits getting the users for all the users. So we have no rule that just tells that a GET request for API users should be restricted to like has role, for example. So we should have something like that here. That would be the correct fashion to restrict API users for some role. Instead, we have a permit all in that case, and that's why the authorization does not work as designed. Then I already mentioned that we have some Sql injection problems inside our application as well. So we can also detect Sql injections using automated tests, like for example here. So I have some tests that actually use well implemented queries, like for example the what I have the find by identifier in the user service. That find by identifier just calls the user entity repository, and the user entity repository is implemented as designed by Spring Data. So it just generates a prepared statement by default for executing this query, and we don't have any SQL injection problems. In contrast to other tests I have here, like for example the verify search bookmarks, for example, that just uses that bookmark service direct GDBC implementation. So that probably has some problems with SQL injections. Also, the defined user by email, for example, should have problems. So because in that case, it does not use the default user entity repository, but it has some custom user entity repository. And in that case, it also implements that in a bad way with just concatenation of strings. And we also would have a problem here. And then now to test actually this stuff, I just defined the typical payload you use probably for testing for SQL injections, the most easiest one to just detect such things. And we just try each and every service with the same injection payload and try to see what happens. Like for example, here for search bookmarks, I would expect that the list is empty with the results because it should not find any result with that payload. But let's see what that tests tell us. So for that test, we also start no web environment. So that's not required for the test. We just test on the service level again. So that also takes a bit more time because it also tests against a real H2 database. As we can see, The only green ones are the ones that are running against the usual Spring Data repositories with auto-generated queries. And the bad ones are the ones that I wrote myself with some SQL injections inside. So like, for example, verify search bookmarks. So it was expected that the result is empty, but actually it just returned all the bookmarks that are in the database for proving that we have some SQL injection problems here probably. So if this is quite easy tests, so you can easily just get some SQL injection payload, tackle each service at your application with that payload, and then just put up some assertion. What is really expected, that it should not find any result or should also not find any single result, for example, if you use a Java optional, for example. And then if this is not the case, then either you have implemented completely wrong, your query is not doing like what is intended to do, or you probably have really a SQL injection. What I did not show beforehand was that we can also tackle these things already on an architectural level. So maybe some of you already have used what is called ArchUnit. So with ArchUnit, you can also write tests testing your architecture of your project. Like, for example, you can have general tests like testing for your layered architecture. There are also predefined tests testing for onion architectures, for different kind of architectures we usually use in our good projects today. So like here, for example, I have the layered architecture. So I've structured it with a layer of controllers, with the REST API, with services, with the business logic, and a persistence layer holding all the entity beans and repositories. And here you can just test that, for example, the controllers layer may not be accessed by any other of these two layers. So it's not intended that the service layer should call any controller layer. Also, the services layer may only be accessed by the controller layer. So it should not be accessed by the persistence layer. And also the persistence layer should only be accessed by the service layer then again. So you can easily just test that by using ArchUnit. And that way we can also have security related tests, like, for example, insecure persistence architecture tests. So you can test that your services or API should not use any classes coming from these packages. So like, for example, direct use of Java SQL, Java persistence, or Spring Data class, or even Hibernate classes should not be used inside a service or API class. So these at least should only be used on the data access layer. And also in the data access layer, we prohibit direct use of Java SQL, Java X persistence, or direct use of or Hibernate stuff. So that makes it much more difficult to really have SQL injections. Because of that, you cannot easily use Entity Manager using with SQL, with native SQL queries, which we have. And if we just run that test again, that should also fail for our application, because, for example, it detects that our custom bookmark entity repository, for example, calls methods like Java X persistence entity manager create native query. So that's detected by that architecture tests already. And these are all unit tests level. Another idea of testing for security is to also test for input validation. So these tests make sure that that all fields that are declared in classes that are, for example, entities, should have at least one of these annotations in place, like the typical constraint annotations. And same should be true also for that the REST controllers, that they should also be annotated with the validated annotation by Spring Framework, so that the validation is really kicked in also on the REST APIs. So like, for example, this makes sure that we have the input validation in place. And also regarding authorization, you can also put in some architectural tests. Like in that case, I want to make sure that each and every public method in that case, so we can have here methods that are public, then are declared in classes that are have the name service inside, that also are annotated with the service annotation of Spring. And all these public methods should be annotated with the pre-authorize annotation to really have authorization in place, and or they should be declared on class level, that pre-authorize annotations. So that's also okay if you put it on a class level. But as you can see on our services, we don't have any pre-authorized defined, so that tests here should also fail. So we can prove that. So if we look down here, so it analyzes lots of classes. And now we see that almost no service does have the annotation on that class, so it's not annotated with pre-authorize, and this is a really bad form, so that there is no authorization in place at all. This case, you can write plenty of architectural tests that already on the architectural level tackles security problems. So the last layer I want to present is the layer with the most effort required. So it's about dynamic application security testing. Here you will have the usual tools that also pen testers use, like the OWASP tool, for like a web proxy tool with automated security scan possibilities. And you can also have a commercial variant of that OWASP thing, like called Stackhawk, that especially makes it much more easier to do authenticated scans automatically. We have the commercial Burp Suite, and also tools like SQL Map, Nmap. These are also pretty much tools that you can put inside your CI/CD pipeline, for example, and also do automatic testing on nightly basis, for example, because sometimes it can take quite a long time depending on what kind of scanning you are doing. Like, for example, if you use the full-blown active scanning suite of OWASP, then this could take up some hours depending on your size of your application. SEP, for example, comes quite handy for automated testing because it provides Docker container to do the testing. So you have three possible variants of containers of OWASP. So the baseline scan especially is quite fast. It just runs a baseline scan only using the spider to find new links, new API links, new pages on your application, on your web application, and just does a passive scanning that is not really dangerous. It just detects some stuff like missing headers, missing HTTPS transport security and stuff like that, which you can easily find by just browsing an application. Then you have the API scan that you can use, especially for my case, testing an API. You can just put in some open API definition, and then OWASP tests against these provided API URLs with some predefined scanner stuff, especially for APIs. And you can also have a full scan. Then this does really a full active scan, plus an optional AJAX scan for single page applications. This takes pretty long. So for today, I just brought in some sample using the API scan against my application. So I think my application still is running. So we have SEP here. So I've just prepared some scripts running over SEP. You can have a stable Docker image. You can also have the weekly images of OWASP SEP. So these are with more functionality, but not that stable compared with the release Docker stable one. Then you have to provide the targets of the API docs specification, where it gets then the URL that are provided on your REST API that it should target. You have to specify what kind of documentation it is. You can have Open API. You can also have a GraphQL documentation. Then you can also provide options to the scanning. In that case, I just provided options to make sure that I have an authenticated scan. So I provide the authorization header with a basic authentication in that case, so that we can also scan the authenticated parts of my REST API. Then I also create some API reports, XML format. I also have some hook defined here to also influence some parts of the application. So you can just write a Python script where you can just hook into different stages of OWASP SEP actually. So in my case, I just hooked into the active scan, and I just imported an extended scanning policy that does a bit more than just the API scan policy, called the Spring Boot backend policy. And we will see how that behaves. Just try to start that scanning process. So hopefully this works. So as you can see, that also takes a bit more time than even the integration testing we had before. But it should be much faster than using the full scan of OWASP SEP. So we see that it has imported 12 URLs from the API docs, which it grabbed for my address here. So localhost is not working with the Docker images, so I have to provide the real IP address of my machine, so that Docker can reach it. And now it tries to do an active scan. Originally, it uses the policy API minimal, but in my hook, I just have overwritten that policy with my own policy. So shortly, we should see the results of the scan. So with patience. So in the meantime, we should also see that it also has, where is the application? Yeah, we see that the scanner is running because it gets lots of error messages on the console here. Check back. So the scanner has finished. So it found several bad things, like it detected some server error response code, which should not have, you should not have a HTTP status of 500. It detected some header missing. So this is from the passive scanning. also saw some cookie stuff. Then it also detected maybe a buffer overflow. And it also detected SQL injections, like, for example, in our search bookmarks API. Also on the standard bookmarks using the user ID, it also detected a SQL injection correctly. Then it also detected some cross-site scripting weaknesses in the JSON responses. And also saw some application error disclosure in the change password function, like here, for example, the 500 HTTP status. And this way you can also put that inside your CI/CD pipeline using that Docker image. And this would conclude the last layer of the security testing pyramid. And as mentioned, you should automate all these things. So I've just shown some first ideas what can be tested regarding security, like SQL injection, input validation. What I did not show was one test. Maybe I can, for the last time, also show a security misconfiguration. Like, for example, you can also test what is also a typical problem always. Oh, my wife, just 1 moment. So that's always what happens when your wife is shopping and does not know that I have some talk to do. So you can also test for cross-origin problems, like the usual thing that we just defined, that every client can just access our backends, like putting wildcard like a star for the origin. So you can also test these things here, so that, for example, the invalid origin, like evil.com, is not allowed to access it, but the valid origin is allowed to access it. So we can also test that one. So that should also fail most of parts of the tests, because we also have defined that quite open in our case. Like here we have that course configuration with the wildcard defined, so it just accepts any origin, which is quite bad. So we can also test that the cross-origin pre-flight request, for example, it should disallow get, post, put, delete for an invalid origin, but actually it allows it. So we get a 200 instead of a 403, what would be expected. The other case is that for the correct origin, it should get through, so that works as is expected, even with the wildcard. So for example, for a post, we get back the intended access control origin headers, also that these methods are allowed. And we can also test that in our integration tests, like, for example, here, that we also have that header in place. And with that, we have here the full security testing pyramid again, with dynamic stuff above, that then authentication, authorization on the service level, input validation, broken authentication, stuff like that, and static analysis on the unit testing level. So on the top level, you have the explorative testing. You can also have what is called charters on explorative testing. So you can have some 1 hour testing for your developers, for example, just tackling all input fields and putting all the rubbish you can find in all input fields and see what happens. So that would be one idea of a security charter, for example. just give them 1 hour that they can just put in all the nasty stuff that they think of in each and every input field. Or doing security code reviews is also part of that. And then, of course, external pen tests are also on that level. And with that, this is the end of my talk. Are there any questions?
Perfect. So 1 moment. There I am. Andreas, do you hear me?
Yes. Yeah.
Perfect. All right. Awesome. Thanks for the presentation, everything. Or did I miss something, or are you finished so far? Because I got a few questions.
I'm finished. Yeah.
Yeah. Awesome. Perfect. So first of all, thanks, Andreas, for the really cool talk, especially like the demos that you showed us. I got a few questions in the chat, but they were directed to me directly. So one of the questions is breach password test. Do you really have that in a unit test? Doesn't it generate a lot of traffic or mock it?
Yeah, if you use really breach tests against a database like Troy Hunt's breach database, then this would be more like an integration test. So for unit test level, I would advise to just download a list of top 1,000 passwords, for example. That would be an easy first start for unit testing against well-known passwords you should not use, like test 1, 2, 3, 4, 5, 6, stuff like that.
Mm-hmm.
That could be easily done on the unit test layer. Just load that file via JUnit 5. You can also have CSV files automatically used in your tests. So that's an easy part.
Perfect. Another question was, wait 1 second, was from Preisinger. What's your opinion on test-driven development? Have you ever seen in being used in practice in the real world?
Oh, that's a good question. So everybody always talks about you should do test-driven development, but what I recognize, it's not really useful in practical. It's not really useful in all cases. So it's always difficult if you have to implement new functionality and you don't have even 1 line of source. Then you should start with a test before having a rough idea what would be the first line of source code, and these things makes stuff a bit difficult. So I find it quite useful. For example, if I want to write a new REST API, for example, if I want to implement a new REST API controller, then I usually write a mock MVC test beforehand. That is quite handy, because then you get a 404 when your test runs, because the REST API does not exist. And then you implement the REST API, and then you should get a 200, or if you get a 500, then you implement it in the wrong way, that REST API. So this way works really good for at least the REST controllers. So I use that pretty much. But for other parts, this does not work that well. So if somebody tells me so he or she does test-driven development all the time and for all cases, so I would not expect that as a reality.
Yeah, I also have to say something on that. I do believe that, everything that you put to the extreme is going to cost you a lot of time in the end. And that also includes fully 100% test-driven. I don't think everybody does it 100%. Or if somebody does it, I don't think they're efficient. So when I find this very handy when I have something that is something that has a very narrow interface, and I'm implementing something that is new to me, that I don't know how to do it. So I define a set of inputs and I define a set of outputs. I have an example. I recently implemented file encryption and decryption in JavaScript in a browser-based application with a service worker. And that was something I had to use readable stream API and stuff I have never used before. So I defined, this is my input, I want this to be the output, and I have a couple of examples and a couple of edge cases. For example, I have 1 byte less than the block size, something like this. And then I start writing the solution. So if I'm exploring something new, but it has a narrow interface, that comes in very handy. But in some other cases, it can, it cannot be as useful.
Yeah, in that case, I also use it. Like, for example, I also had a case where I have to learn now how to do zip files in Java with getting also protecting with a password these zip files. I did not do that before, so I also write a unit test that gets some files in that should be zipped, and then I just unzip to prove that the zip has worked, and unzip with the provided password. So that's a great thing to do in test-driven development.
Yes.
But as you have told, with narrow things, that works pretty good. But
yeah.
if you have bigger, complex, much more complex things, then I have my doubts if that works 100%.
Mm-hmm.
So it always the consulting answer, it depends.
Yeah. We have a couple of other questions. Nikki, is that okay if I just take over?
Yeah, sure. I
Okay.
already thought so much.
Yeah, Nikki just took over because I had to look after my daughter for a minute. But now I have time again. So, breach password test, that question was already asked. The next one is by Walter in the Q&A functionality of Zoom. He says, really like the SQL sec testing, but my experience so far is that for things like queries or DB related stuff, I can only do mockup tests because not having full access to database. In your opinion, is some of it also applicable in that context, or how would you go about maybe adjusting tests in that case? Could you share more resources, frameworks, or other languages besides Java? So there's many fuzzy questions in here.
Yeah. So in my case, I also do not require to have access to real production database. I just tested in my case with an in-memory H2 database in that case. So that should also work if you don't have access to the database directly. Yeah. If you have no access to any database and you have some other third party that is doing the persist, then it's really difficult to test.
Yeah, that is. So I'm also developing software where what I have is I use Sql in production, and we have an SQLite database that's just file-based, like I think H2 works pretty much the same way. It's a very lightweight Java database, right?
Yeah.
So we have test data that covers the most important processes, and we have test users with just test parsers. You can log them. You can make a service security test, for example, by logging in that test user and then interacting with the API. So having a good set of test data is something that comes in very handy. Of course, when having a very complex application that deals with lots of different states and data, that this is very hard to get. But when it's something smaller, just coming up with a set of test data and putting that into a file-based database like SQLite or H2 is something that's recommended also from my part.
Yeah. So if you're also a friend of Docker, I also uses, for example, the production database. We use the Oracle production database. Then we also use a Docker container for using the Oracle database in our integration test. That takes a bit more time because Oracle is not the fastest database by a startup, but there is a possibility to create such pre-built Docker container for Oracle that also runs quite fast. And then you can also test against the real production database at least. So that's also great.
There's also a question from Andreas in the chat. He says, is there a typical set of security tests available to start with? And the second question is the bookmark service test project open source? I think it is because I think I saw a GitHub link, right?
I think I sent the slides. It's also recorded in video. On the title slide, you have the link to the GitHub repository. I can just there you should see the link github.com/Andify bookmark service.
Right.
So it's planned to extend that repository also. That's just the first start because I want to also offer the secure variant of that application. So that they can see that all the tests I've shown today then switch to green if I provide the secure variant of the application. For me, it was interesting to see that tests really fail if you have a security problem. So it's boring to see only green tests.
Yeah. I have another question. That's my question. What does it get you when including backend tests that just reference front-end tests, or something that you cannot do in a JUnit test, for example? What does it get you to include basically an empty test there?
Yeah, for me, it's just a marker for me so that I don't forget to do that test on the front end. So I see it every day that test is ignored, and in the source code, I see the reason why it is ignored all the time. And so you can also add some to-do markers above that.
Okay.
So I found it quite handy. So to also add these tests as empty tests, just not to forget them, to put them in the right location in addition.
Okay. And another question that's also, I'm asking that because I never used Zap really myself in a project, but I really want to do that because I think it looks really easy to get started with the Docker container and start a Zap test.
Yeah.
My question is, how do you get Zap to log into apps that require authentication? Or second question related to that one, how do you Zap to get to create a certain state? Maybe I have to, I don't know, enter 2 form steps before I get the 3rd form step where I want to do dynamic tests. How do I get Zap to know how to use the API with known good requests?
So for that, it's always advised to before going into automation, just use Zap with the UI against your application to learn how Zap behaves with your application. Really, just use the usual interface of OWASP interactively, and train Zap to understand your application, how to authenticate, how to learn all that URLs that are provided by your application. And then you can also save the context and of that learning phase, and use that context also in your automated tests as well. In your context, you can also configure, is it using a form-based authentication, which are the users to authenticate, which are indicators that the authentication was successful, and you can also have signals, what is the logout indicator, so that Zap knows if it's in the authenticated state or not in the authenticated state. But
can I also write this manually, like have context as code, buzzword alarm, somewhere in my repository, so that if something changes or a new form is added to the application, I can add that to the context as well?
Yes, I think you can load the context into Zap again, and then just continue starting and then get an updated context, for example.
Okay.
So that's also advised by Simon Bennett, the inventor of OWASP, always before directly diving into the automated part, just try it first on the standard OWASP UI-based tool.
Okay. So that's probably the file
if you have an application, not a REST API. The REST API, it's more easier to just provide that open API documentation, for example.
Yeah, but what I fear when I just provide it with the OpenAI documentation is that it doesn't know, well, if the OpenAI documentation does not contain valid values for certain post requests, for example, or just sample requests that are not real, and it's going to throw me an input validation error that I don't get deep into the application because it's always going to get stuck at the input validation layer and never touching my real code.
That depends on how good your OpenAPI documentation is. You can even provide also examples in your OpenAPI documentation. So Zap gets an idea what are typical input values.
Yeah, so it would really make sense, and I think that's what I wanted to hear as an answer, is that you have maybe test accounts that you can log in with, and those test accounts are exactly also in your OpenAPI documentation. Make sure not to deploy that to production.
Yeah,
that's important, but have the OpenAPI specification aligned with your test data, because then you can provide Zap with that OpenAPI documentation. It's going to be able to log in and do some actual scans and not being stuck always at the login screen. I really have to try that out.
You can also have the ability to just store all the URLs that you have tackled when manually testing all that stuff, and then provide these stored URLs to the automated test. Okay. Then it gets also more accurate with your real URLs. But the most difficult part is really the authentication in using OWASP in the automated fashion, especially if you have then also token-based authentication, stuff like that. Then how to get that JSON web token if you especially use like something like Keycloak and a third-party identity provider where you can have to get the tokens from. So that makes things much more difficult.
Yeah, and that might require that you have maybe a user authenticator that's also just working with a test JSON web token that's not a real identity provider. Might make your life easier than for test purposes, setting up a whole infrastructure, including Keycloak with a configuration. Maybe better to just basically mock that. Also, again,
what we do, So for testing purposes, we just have our own signed JSON web tokens that are validated by the backend, and you can just easily create your own JSON web tokens, but only on the test environment.
Yes, and you with those frameworks like Spring and others, you have the possibility to define your environment. So that's the dev environment, it's a test environment, it's a prod environment. So you really have to make sure that this is only available in the test and it's not deployed to production in a way that it can be used. That's really important.
But this way you can also improve authenticated tests, because with authentication, you don't want to do penetration testing also on your third-party identity provider, which also
exactly. And it's going to be slow. If you have a whole Docker Compose environment with lots of dependencies, going to be slow, and there are lots of more moving parts. Means it takes longer. It has more. It's more prone to errors, and there's a lot going to be going wrong. So it's basically, in this case, better to keep it slim because it's going to be quicker.
Correct.
All right, Andreas, thank you very much for again being part of the meetup. Looking forward to your proposal for Sec4Dev 2022. Hope that's going to work out this time.
Maybe an extended version of that, also including front-end stuff. There is also nasty cross-site scripting stuff to be tested for your front-end.
I recently looked at SemGrep for React applications.
Yeah, SemGrep is also a great static analysis.
And it's basically the disadvantage is that it lacks context. It can only look at that one file you're scanning. It doesn't have any taint propagation through various files, but the syntax is very easy. And for specific things like not using the influences in HTML or bypass security trust HTML in Angular, that's a very specific thing. You can basically grab it out in one line. It's very good and very quick to find those spots in your application. So that would be great to have a look at this for maybe front-end frameworks. Yeah, that sounds good. All right. Thanks everybody for being here at this meetup again. And if any of your colleagues could be interested, I think that was a very good summary of what you can do at what level, what advantages, what disadvantages this has. If you want to share this with your colleagues, we're going to be posting the YouTube link in the meetup event afterwards. Nikki's going to do that. And yeah, please share and speak to the world about this meetup, about the cool contents that we have, about the cool speakers that we have. And hopefully we're going to see some of your colleagues as well and friends and relatives at the next meeting. Thank you, everybody. Have a nice evening.
Yeah.
Thanks, Andreas, again.
Yeah.
Thank you, Andreas.
And see you in Vienna next year.
Yeah.
Yes, we hope so.
Perfect.
Bye.
We had our first meeting on Sec4Dev on getting it started for next year today. So it's going to be awesome.
So when is the call for papers open?
Probably soon. Soonish means I'd say in a month from now, end of June. But that's just a rough estimation. That's not a promise.
Yeah, just a rough that I can plan it for my time.
Yeah, that would be cool.
Okay.
Thank you, everybody. Have a nice evening and see you next time.
Yeah. Bye.
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 Bye.